Hello and welcome to today's Silver Spring Networks webinar, The Rapid Telemetry Edge, Market Trends and Technology Drivers for High Performance Demand Response. I'm Winston Lazar, Product Marketing Associate at Silver Spring Networks. Before we get started, I'd like to take a moment to go over the screen in front of you. You'll notice there are several windows and a menu bar along the bottom of the screen that allow you to customize your screen. Some features that may be of interest include you can enlarge the webinar area. Just click on the box on the top right corner of the presentation window. The resources window on the left has links to more information about Silver Spring's demand response solutions. Please note also that you'll be able to enter questions at any point throughout the presentation through the Q&A box located on the lower left-hand side of your screen. We'll have a 10 to 15-minute Q&A segment at the end of the presentation today, during which we'll allow you to address any of the questions you have over the course of the webinar. I'll go ahead and address the most commonly asked question. Yes, the webinar will be recorded and available for replay. You'll receive a link by email after it concludes. Today's webinar will feature Brett Feldman, Senior Research Analyst for Navigant Research, and Matthew Smith, Senior Director of Product Development at Silver Spring Networks. Today we'll discuss some of the ways in which utilities are looking to leverage demand response as a distributed energy resource. We'll begin with the webinar with a presentation on the overall conditions in the demand response market. We'll discuss some of the ways in which demand response has been used to date, sharing examples of some of the most common applications for demand response in commercial and industrial markets. We'll continue by diving into the trends and market drivers that will shape demand response markets as they continue to mature. Finally, we'll showcase cutting-edge technologies that will enable future applications and widespread adoption of demand response markets looking forward. And now I'd like to introduce our first speaker, Brett Feldman. Brett is a Senior Research Analyst with Navigant Research, contributing to the Utility Transformations Program. With more than 15 years of experience in the utility sector, Feldman focuses on demand response programs and their implications for the global power industry. Prior to joining Navigant Research, Feldman was a principal for demand response at Constellation Energy. He also had served as the chair of the New York Independent System Operator Price Responsive Load Working Group, the vice chair of the Independent System Operator New England Demand Response Working Group, and the co-chair of the Northeast Energy and Commerce Association Energy Efficiency and Demand Response Committee. The chairman of the Business Issues Committee for the Association of Demand Response and Smart Grid, Feldman is also a member of the Town Council in Franklin, Massachusetts. A certified energy manager, he has experience across multiple markets, including ISO New England, New York ISO, PJM, and Ontario. Feldman holds a BA in economics from the University of Michigan and an MBA from Boston University. Thanks for joining us, Brett, and now I'll hand it to you.
All right, thanks for that great introduction, Winston. It's great to be back with Silver Spring. I was on a webinar just about a year ago talking about demand response with Silver Spring, so it's good to give an annual update on what's happening in the industry. There's certainly a lot of new developments to go over. So as you heard, I'll give a little bit about the drivers for demand response. We'll talk about some current trends in the industry, and then we'll also look at some future developments that might be the next stage of data and demand response. So looking at some of the current drivers, there are a number both on the technical side and more on the policy and market side of things. So from a technology standpoint, a couple of the biggest drivers have been advanced metering infrastructure that's been installed throughout the customer base in the U.S. and across the world, and you'll certainly hear from Silver Spring more about the type of enablement that allows as opposed to the old standard types of monthly analog meters. Another thing on the customer side is smart thermostats. So instead of the old one-way dumb type of programs, you can have two-way communication with devices that allow customers a lot more control and also have more learning capabilities. So I think those are technological advances that will help drive VR. And then more on the policy and market side, there's a number of items you can see here. So first is getting into ancillary services market, not just focusing on the traditional emergency capacity types of programs, but getting more fast response. Second, and every time I do a presentation, I try to talk myself into taking out the duct chart, but I can just never seem to do it because it's such a great visual. So we see here the duct chart from the California ISO. It's been around for a couple of years, talking about integration of intermittent renewable resources. So the load shaped in certain parts of the country and the world are going to change rapidly over the next several years, and you're going to need some new types of flexible resources to balance out those renewables, and demand response can certainly play a role along with other options. Another big driver is dynamic pricing, getting more time of use rates, critical peak pricing, peak time rebates. So I think you're just going to see that expand. It's already moving ahead in California and Massachusetts and Ontario, and I think certain states and utilities will advance that aspect to drive more DR adoption. Then kind of an overarching theme is grid modernization, the term you hear. So there's things going on in, like, New York's reforming the energy vision. California has a plethora of different undertakings regarding demand response and all types of resources to modernize the grid. Other states are doing it. It's just a trend that you see that's going to lead to more distributed resources in general, certainly including demand response. Grid resiliency, which came a lot out of Superstorm Sandy a few years ago, just having more control to be able to respond to natural disasters or any problem on the grid. And the last one is environmental benefits, and that's taking on center stage these days with the EPA's Clean Power Plan coming out a couple weeks ago. So there's certainly a place for demand-side measures, including demand response, to play in reducing emissions. Just a couple other drivers I want to mention. This focuses more on the technical side, and so as we talk about data and communication and control, standards are going to be very important. And instead of all different vendors using their own proprietary systems, the biggest one these days is the Open ADR standard that's started in California and is really proliferating across the globe, as you can see here. It's a way for all different types of devices and vendors to communicate with each other in a standard protocol to be able to manage demand response programs. Then you also have things like the LEED from the U.S. Green Building Council that now includes LEED points for doing automated demand response. And then the last thing here is California's Title 24 building code. On a state level, there are also things that can be done to require or encourage new developments or large retrofits to have demand response capabilities as part of their upgrade. So all those different types of drivers can really move the demand response market forward. So now I want to just give a little bit of background on the types of telemetry requirements and communication that we're talking about here in the marketplace. So we have a table here. I'm not going to go through all of them, but you can just see that the different independent system operators and regional transmission operators, there isn't really any single standard for data capture and transfer throughout the industry. This is something that's been tried through NASB, but at this point, it's still very regionalized. So on the right-hand side, you can see it ranges from the frequency regulation market, which is in a number of seconds, to, in the day-ahead market or emergency market, you can use hourly data, and then if you get into some programs or reserve programs, it can be 5 minutes, 1 minute, anything in between. So there is quite a range these days, but I'd say a general trend is that they're expanding programs to include smaller customers and residential customers. So you will need more real-time telemetry as you get into disaster response types of markets. So looking at what this means on the customer side of the meter, typically on the commercial and industrial side, the utility meter is not sufficient, or at least it doesn't provide all the information that the customer or the demand response provider would want to use from an operational basis. So a lot of times you need additional metering communications equipment to be installed on site to capture data from the utility meter and to communicate it. And that can be a few hundred to a few $1,000s per site, depending on the size of the facility and the level of technology. So that does present some of a barrier to customers participating if there's going to be some kind of longer payback due to that investment. So, and ultimately, if there are utility meters using AMI infrastructure that can transmit this almost real-time interval data, that can remove a lot of the cost of participation and lower the barriers. So, again, I'm sure we'll hear a lot more on that from Silver Spring. And this doesn't just affect the C&I customers. It is also creeping into the residential space, as we'll talk on the next slide about some developments in the ancillary services market. But just in general, it's not feasible to put high-tech equipment on every customer on top of the utility meter. So if that utility meter can do the job, then it'll make it much more feasible in the mass market as well. Here's an example of an interesting recent, win for the demand response community in the PJM synchronous reserve market, which is a 10-minute spinning reserve type of a product. There was a long stakeholder process over the last year or so, led by Converge, that was able to allow for residential customers to participate in this market, which really isn't done anywhere else in the U.S. at least, because it does require very 5-minute or 1-minute data, and it's not necessarily feasible to get that from every customer unless the utility has already installed all the AMI infrastructure. So there was a process to make PJM and to make the rest of the stakeholders comfortable with a statistical sampling approach. So only a certain number of customers would need to have this full-fledged data and communication in order to get a large swath of the customers to participate in the program. And I'm not going to read through all the technical specs here. There's pages and pages of details in the PJM market rules, but suffice to say they try to look at all the different parts of this project, what it would take from a technical standpoint, so there's study requirements and data validation and estimation, and then on the customer side you look at churn, because certainly in a residential program you're going to have a lot of turnover, even month to month, so you have to account for that. And then lastly, just on the market offering side, how that would take place on a randomized basis, so someone's not trying to game the system. So it'll be interesting to see how that opportunity plays out and if it expands into other regions as well. So going from the customer side to more of the utility control side, when you talk about demand response and data management, is the idea of a demand response management system known as DRMS. So it's a nice graphic that I've seen that shows a lot of different functionalities and how it flows through utility systems all the way to the customer. And DRMS do a lot of different functions, taking in AMI data and other sources of data from devices and weather and all different inputs. So you can forecast load, forecast the availability of demand response. You can do load shaping analysis, looking at data. You can check on device status so you know what's actually available in the field. You can dispatch on more of a granular basis and just kind of an all or nothing that it used to be, push the button and just turn everyone off. And then you can really go to a locational level to where a system really occurs. You can do a lot of different life cycle program management for DR, enrollment, dispatch. An important thing is getting the feedback data in near real time for measurement verification purposes and to be able to adjust things on the fly. So that's a huge addition to the operational assets for a utility, the people in the control room, to be able to count on demand response. And these days it's expanding beyond DR. You hear the term distributed energy resources, so there's DER, MS, DERMS, and then I think the next frontier is just bringing these types of capabilities into a utility system like an advanced demand management system, an ADMS, to just have it more centralized and be one of those core functions of the utility operator. So now I have a couple of slides just looking a little bit into the future, I'd say, getting away from the operational aspect more into the program management and design. So, we talked about in the last slide the availability of real-time data for measurement and verification on the fly, but I think the applications for AMI data will go into more mainstream DSM practices, certainly like we're talking about here, evaluation and measurement and verification. So typically you had to do a study many months later or a year later to get data and put in loggers and do sampling of customers to get data to do an evaluation. But if you have AMI data, you can get that on an interval basis for all customers, really. You can look at pre- and post-retrofit applications and treatment and comparison groups. You can combine the account level data with some of the traditional engineering analysis for HVAC and get a lot higher precision at a lower cost. And you can also use AMI data to examine demand savings and look at things like DR as opposed to just using monthly data, which doesn't really help you from a peak situation. You can also get down to the feeder level by getting this data on a localized individual customer basis. And I think you probably start to hear the term something like auto M&V. You have to come up with something clever, M&V 2.0, auto M&V, something like that, where you'll hear about just being able to do these types of evaluations on a quicker, more automated basis. The last thing I want to talk about is, I guess maybe the furthest point looking out at the use for this type of AMI data is what I'm calling analytical demand-side management. So this is the concept of the term virtual audits or remote audits. So again, a typical DSM program has people going out to a commercial industrial customer and doing a facility walkthrough. You have an engineer doing this and estimating usage, or on the residential side, you have people going door to door and doing home energy audits. And that can be very costly, and you don't really, it's kind of a crapshoot as to who you're targeting. But once you have this data available, there are companies that are coming out with tools to analyze interval data, a year's worth of interval data, and apply some statistics to it and regression analysis to really figure out what the usage is in a facility without even setting foot in it. And then you can prioritize your targeting for customers instead of going on a random basis, and you can customize your messaging to customers. So this is a way to look at consumption from a large number of customers and reach out to them at a much lower cost than doing a bunch of on-site audits. You can target what types of customers are likely to benefit from energy efficiency and demand response. You can do geo-targeting if you have a certain area you want to look at. You can do resource potential studies. You can look at how DR can integrate with other distributed energy resources like storage and renewables to assess interaction. So I think this is really going to be the next level of where we see uses of data aside from just day-to-day operations. And just a quick plug, where my next report is on analytical and behavioral demand-side management, where we'll be talking about these types of new opportunities in the industry. So with that, I think I'm on time here. I'm happy to turn it back over to Silver Spring. You can see my contact info here, and let them talk about their capabilities. So thank you.
Sure. Thank you very much, Brett. Please do check out Brett's research on Navigant's website. It's really excellent. I would recommend it to anyone. So with that, we're going to move over to the Rapid Telemetry Edge. Matt Smith here from Silver Spring Networks is going to present on some of our new technologies enabling the demand response market. Matt Smith is a Senior Director of Utility Solutions here at Silver Spring Networks. He has over 20 years of entrepreneurial experience in energy management, home computer, and consumer electronics industries, most recently at Greenbox Technology, an early leader in customer-facing smart grid applications, where he was head of marketing and sales. Matthew earned his MBA from the Presidio School of Management and his BS degree in computer science from the University of Pittsburgh. With that, I will hand it off to you, Matt.
Great. Thanks, Winston, and thank you, Brett. Lots of great information there. So I wanted to talk a little bit about what Silver Springs is doing on the telemetry space as it relates to demand response and distributed energy and energy resources. Silver Spring continues to evolve its smart grid vision and providing key networks and data infrastructure for multiple applications on a common network infrastructure. Traditionally, this has included automated metering infrastructure, distribution automation, demand management, as well as demand response. Typically in a more of a silo type of approach, which is traditionally how utilities have provided those services. But as we look forward, we're really starting to see more of a unified grid management operation where these once separate silos are starting to really come together and really look at a unified grid operations model. And so this includes demand response assets, devices that are in customers' homes that are under the control of the utility in the future, including distributed energy resources such as solar inverters, storage, but combining that with information from smart meters that are already deployed, as well as grid sensors like line sensors, voltage regulators, to come up with a common information model. And this could be both on a centralized control structure where all this data is feeding back into a centralized operations and control and be managed from the head end. But increasingly, we're also starting to see applications of distributed control where this telemetry data may be coming together at the grid edge. And so regardless of the control methodology, what we really see the common element here is telemetry information from all these various devices on the grid coming back to a centralized place or distributed place, and that data being used to make better decisions about how to manage the grid. And so what we want to do is to talk a little bit more about that telemetry and what Silver Spring is doing in that area. Specifically, if we look at demand response historically, information, telemetry data around homes and businesses that are involved in DR programs, has been collected in the past, but it's primarily been used for program validation, not really operational control. And traditionally, the grid operations folks haven't had a lot of visibility into the demand response programs other than what may be provided by SCADA or other types of control, which you really get a total grid level, not really looking program by program. And so in order to realize this vision of a unified grid management, one of the key things that we need to be able to see, or operators need to be able to see, is greater visibility and knowledge about what these various demand response or distributed energy resource assets are going to provide when those devices are called upon. If we look at what that looks like, there's a graph here that shows demand response and when it's typically utilized throughout the year. Traditionally, DR has really been used for capacity purposes, being able to provide relief when demand on the grid is the highest, typically in the peak days of the summer months. That's what these little red dots on the top line graph there show you, is they're each individual events. And you can see that traditionally DR is used just really a few times per year. But as we start to think about how demand response assets can be leveraged in other types of programs for ancillary services, reliability type programs, or for balancing out variability from distributed energy resource, you can see that there's a need or a potential for these DR assets to be used, throughout the year. And so, but the difference between doing that, using them throughout the year and using them just on the peak summer months, means that they're used in a lot more creative ways. They're used in very specific parts of the grid versus just the whole area. They might be used for different situations. And so as you increase the variability of how DR assets can be used, then that also drives a need for greater visibility and intelligence on how they're going to respond in different situations. If you're calling an event, a capacity event, where you're calling the whole fleet just on a few days a year when the temperature is typically always the same, you can get a pretty good understanding of how those devices are going to respond. But if you're calling them across a much broader range of temperatures, different grid conditions, smaller subsets of the total fleet of DR assets, then having this advanced telemetry data can help you gain greater insights into that. And so what we see is that in order to create the type of operator confidence that utility operators will need to have the confidence in these events to be able to rely on them in these various situations, having detailed information system that's going to not only tell you what happened when you called an event, but increasingly be able to predict in advance what you will get prior to calling the event based on historical performance, current grid conditions, temperature, a whole range of assets that would be ultimately fed into a demand response management system becomes really critical. And so being able to pull those things through so that operators can precisely target events, can target the right amount of megawatts that they might want to get, and then verify once they have called the event that they're actually getting what they need at a detailed and accurate level is a key requirement to drive forward. And so this detailed telemetry data, as Brett had showed, typically in the kind of 5-minute or 1-minute interval, depending on how long your events typically are, becomes a critical asset in really being able to drive these new software big data applications. So this type of telemetry data has been around for some time in traditional demand response programs, but as I said before, has been traditionally used for program validation. So this means that you would actually get that once a year, you collect it, you maybe do some analytics on a couple events that you ran during the year, and then after the end of the summer, you'll have some third party process that information, verify that your megawatts are what you're getting, maybe submit a report to the commission to verify the validity of the asset. But it's not really been used as an operational tool. And so having data that's coming in real time while events are going into a database, going into an expert system like a demand response management system, and utilized for operational purposes, really a new capability that's evolving, in the market. And so being able to have that information and give it and manage it in real time creates some new opportunities and new benefit streams for utilities as it relates to demand response assets. And so we'll talk about those a little bit more. And so one of the key benefits here is really a cost-based benefit, where if you're already deploying smart meter infrastructure or have deployed that, those assets can be leveraged for this purpose, and that eliminates some program efficiencies that typically exist in DR programs today. And so those are things like installing shadow metering equipment that would be installed in either some subset of homes. That data is pulled back for verification purposes. Those costs can be eliminated in DR programs because you're just using the intelligent smart meter that's already installed. You can also have greater accuracy because even though some markets and some areas will accept and PUCs will accept the statistical sampling model, there are inherent errors that are involved in that when you're sampling a subset of the full population versus sampling the full population. And so what we would imagine with our rapid telemetry solution is that utilities would be pulling detailed telemetry data for all customers, and therefore that creates a higher level of accuracy because you have more data in which to derive your load shed estimates from. There's also some benefits in our solution, and I'll talk about this a little bit more, in that this data is collected completely independent from the meter to cash billing information that's out there, so it doesn't drive any internal downstream changes that would come from that. And there's also some advantages here once you start to pull DR aggregators into the mix, whether those DR aggregators are in contract with the utility or potentially working directly or bidding directly into the ISO. There's some key advantages that come from being able to provide those DR aggregators with this information as opposed to them having to go collect it and go to the expense of collecting it themselves. And so, you can go to the next slide. So another key advantage that we see on this side comes on the customer front. And so while the other areas I talked about were really on the grid operations side, having this detailed telemetry information can fuel new customer engagement strategies as well. And so where typically, in traditional demand response or other areas, a customer may have gotten a phone call or an alert, text alert, or an email when events are starting, and then maybe in the best case, a few days later being able to get some kind of text message or view some web portal in terms of what their results were. Having real-time telemetry can allow in-event type of messaging. So if the customer engagement system was able to receive this data and then be able to track whether or not the customer was responding as expected, in-event messaging could be added that would alert customers to, go take some action, or we notice you're receiving this type of a response. And through that additional customer engagement, you can increase the amount of load shed that you're getting on average because you're driving a greater customer response, as well as, we believe, creating greater customer retention because they're getting better information on the project, know what type of savings they achieved by participating in events, which will decrease churn that you see in typical demand response programs. And so I won't, as we look at adding up those benefits, and this is a summary of that information, and again, obviously different utilities mileage will vary depending on program design, which of these options you implement, but we can see adding up some of the benefits of these various areas that can be driven by more rapid DR telemetry data can add up to as much as $25 per participant on an annual basis. And so that's pretty significant considering that maybe a typical capacity program or a very successful capacity program may be delivering in the neighborhood of $100 today. And so that's about a 25% increase in additional benefits that could be derived from this additional telemetry data depending on what you've been able to implement. And so I think we see a lot of our utility customers starting to think about how do they leverage their either existing DR assets or new DR assets beyond just pure capacity needs. And so you see a lot of talk in the markets, and there's a lot of bidding programs in place for ancillary services, either non-spin or spinning reserves, where you can use these DR assets for basically reliability and grid balancing purposes. So we'll just talk a little bit on how it works. I'm not going to go too deeply into the technology, but I wanted to just give you guys a little bit of a sense. And so this rapid telemetry information leverages the existing smart meter infrastructure that utilities have already deployed. And so it's relying on the smart meter as a sensor for the DR programs. And it will work on both residential and commercial customers, so it's compatible with both meter types. We collect that data, pull it back into the head end into our Silverlink data platform, at which point it can be provided to any third-party application. This could be a utility-run demand response management system that would be taking that data, doing predictive analysis on the types of load shed you're going to get, what you did get after the event, verifying that everything is working correctly. But also could be provided to DR aggregators who are running third-party programs, or directly provided to the local ISO or market for bidding purposes if the utility is bidding into any of the demand response or ISO programs. A little bit about Silverlink. We've announced this a few years back, and as a Silver Spring's entry into the data platform space. It's part of our suite of utility head-end applications that collects data in real time from the smart grid network, processes it, analyzes it, and then makes it available via standard APIs to third-party applications. And this is being used for the DR, for the rapid telemetry requirement that, as you can see in some of the grid apps on top, can be used for a quite broad range of applications, things like voltage management, customer engagement, revenue assurance. There's a whole suite of applications that this data platform will support, along with third-party applications that are writing interfaces to our standard APIs. But it really truly enables real-time data capabilities, real-time processing of information, and moves the utility out of what has traditionally been a kind of batch processing, store and forward model, which creates significant delays in terms of how quickly data can get to applications, into the real-time model. And this is being deployed today by quite a few of our customers and is being used for the DR telemetry. So just a little bit about this in terms of how this works on the back-end standpoint. Traditionally, the data path that's really been used for collecting information from smart meters has really been pulling that data into our head-end system, and then the information is passed on to an MDMS, which then would distribute that data to other applications, billing probably being the most likely suspect, but could be a DRMS or other things. There's some simple validation that's done on that in the MDMS. But what we've seen in those kind of batch processing models, which is how most of that orange data path works, is that any changes to the type of data being collected creates a lot of downstream requirements in terms of changes in the MDMS, in the billing system, and basically creates a lot of headaches for the utility, including potential meter program changes in the firmware on the meter. This has made a lot of utilities hesitant to make any changes for that because they don't want to, basically upset the meter to cache, pipeline. What we've done with our rapid telemetry product in Silverlink is to be able to create a separate data path from that meter to cache pipeline. So while we still use the same smart meter hardware, there's different firmware in our communication card that is reading out that information and bringing it back separately so that you have one set of data being collected for billing purposes and another set of data being collected for telemetry purposes in the DR program. This allows those intervals to be collected at different rates. While you might be doing billing intervals, might be every hour or every 15 minutes. This allows DR telemetry to operate at a 5-minute or 1-minute interval and pull those things back independently and be able to use. So it allows the DR team in the utility to define their data requirements separately from the billing team. And that can apply to any other different groups there. But it really opens up the possibility and creates a lot less work for the utility to add new smart grid applications and have them be able to collect the data that they need to be most successful. So just a little bit deeper view on where the data is coming from. We do, as I mentioned before, collect data from smart meters. But if the DR device is actually also provisioned against the smart grid network, and this could be the form of a thermostat that's connected to a smart meter via Zigbee, or Silver Spring communication card embedded in a load control switch. But if those devices, DR devices, are actually on or accessible by the smart grid network, we can also pull more detailed device data from those devices, combine it with the meter data, and then provide it in a single API to the DRMS or other analytics application that is wanting to do the post-event processing. And so if we go to the next slide, I'll show you a little bit about what some of that data may be in terms of overall capabilities. And you can see that it varies a bit by device. And so on the smart meter side, typically we'd be collecting energy usage information, kilowatt hour data. On a Zigbee device, there's more detailed event data that can be collected, the status of the device, is it in an event, how much energy is it consuming if it has a simple metering cluster support. But in the case of our direct-to-grid devices where we're embedding a Silver Springs communication card into the device itself, we can pull back even more information. Things like device status, relay status, whether the load is on and off in the home, is there a request for cooling from the thermostat, how long the device is in, various energy cycling information. And all of that is ultimately pulled together. And we are actually also working on some enhancements to the Zigbee standard to allow some more of this type of information to flow through a simple energy profile as well. This data then is collected from various load control switches, thermostats. Information is basically pulled back through various software applications within Silver Spring, but then aggregated all together into the Silverlink platform into a time series set of data that can be provided to third-party applications. And so that can be provided through our standard Silverlink APIs. We're also planning on supporting an open ADR 2.0b reporting, then only reporting module there as well. So there's multiple ways to collect that data. We're supporting the standards that are used by most applications, making the integration and utilization of that data simple and straightforward by third-party applications. Silver Spring has our own DRMS offering, but certainly this application could work with any third-party DRMS that the utility is deployed or analytics application. It doesn't necessarily have to be a DRMS that would be doing the processing of the information. And so in conclusion, I wanted to just say that, as we look forward to, all of the different types of devices that will be managed on a unified smart grid, whether they're current DR assets, smart inverters, storage aspects, telemetry is going to be critical for being able to collect and generate and deploy this next generation of distributed energy resource applications and really getting the most out of those assets for things like ancillary services and beyond their use today as typically capacity resources. We enable this M&D in real time, and we can help make these assets really become true operational assets in the control room while reducing CapEx and overall improving the efficiencies of the program. And so with that, I'll take a break, and I think we'll be happy to answer some questions.
Okay, thank you very much, Matt. So right now we'll take questions. You can enter them in the chat box in the Q&A. We'll take questions for the next 15 minutes or so, so please do. But first, we do have one from the audience here. How do you envision AMI data working with smart inverter data? Can you cite specific use cases where you've seen such applications? Many thanks. And Matt, I'll have you take this one.
Okay. Yeah, sure. There's probably multiple levels to answer that question. But primarily, initially, what we see happening with smart meter data being leveraged for the deployment is really on the planning side. And so all of our utilities are collecting data for billing purposes via smart meter, but we see that data being leveraged for analysis of where the distribution grid can deploy and can't deploy additional smart inverter assets. And so our utilities today are using that information for planning purposes when it comes to the approval process for new distributed energy resources. So that's a key application that's being used today by many utilities is for on the planning side. As we start to move forward, there's a key benefit that can come on the customer engagement side from combining smart inverter data, particularly energy generation, with the smart meter data, which is typically a net data, in improving utilities' customer engagement platforms. And so being able to have both of those can give customers the true picture of what their total consumption picture is in the home, which if you just have net metering data is basically impossible to do because you're just getting the net consumption less the generation from the solar inverter. So there's some very near-term advantages there of getting smart inverters as connected devices on the smart grid. And those are all pretty typical things that are being done, today in some cases, although not all utilities have connectivity to the smart inverters. Typically today that requires a second meter. But there's a lot of standards work being done in California and other places today to have smart inverters actually be a device on the network. Once it's a device on the network and it can be controlled, we see future applications either through centralized or distributed control, which would enable enable utility control algorithms to be able to adjust voltages in real time from inverters. So if you use the smart meters as a way to measure what is the voltage at the edge of the network, and if you can start to see fluctuations or areas where, say, smart inverters are causing undesired fluctuations in voltage at the edge of the network, the utility could potentially control those inverters in real time, adjusting the voltage output of that and bringing the grid back in balance. And so, as I said, again, that can be done centrally or potentially in the future either in a distributed way. And so combining smart meter data with smart inverter data and ultimately control of those assets can give you a new level of capability that's not been deployed in the past.
Thanks, Matt. We have a question for Brett now. And how do the various U.S. wholesale markets justify the value of DR? And first I'll give this to Brett, and then Matt, if you want to chime in.
Sure, thanks. So they each have their own market structures, but in general, demand response is allowed to participate or compete directly against the generation resources. So it just depends on the market structure. So in a lot of the markets like PJM and New York and New England, there are capacity markets where most of the value accrues that demand response can play. And PJM is in the middle of it. Capacity auction this week as we speak, where there are some new capacity market rules for all resource types being introduced for the first time. So it'll be interesting to see when the results come out on Friday how demand response has responded to those new requirements, if it's affected the DR participation at all. And somewhere like in Texas, ERCOT does not have a capacity market, but demand response can participate in ancillary services, and they're starting to participate in the energy markets, and there's an emergency program. And I think some of the interesting developments are outside of the wholesale markets too, at a retail or a state level, where in New York, with the Reforming the Energy Vision proceeding, they're really trying to figure out the value of distributed energy resources, and the staff white paper from the Public Service Commission has come up with this concept of the LMP plus D. So there's the wholesale locational marginal price, and then there's the value of D at the distribution level, and the key is to figure out what that D really is. And then on the other coast of California, who's had a working group on figuring out the true value of DR from a planning standpoint, capacity, just looking at all different aspects and trying to add up what the true value is.
Okay, thanks, Brad. Another question for Matt. Is the Silver Spring card compatible with all AMI meters?
It is compatible with all AMI meters that support third-party communications integration. To date, we've integrated with over 40 smart meters. Probably actually the number gets quite a bit more if you take into account the various variations that occur from model to model, but core models is around 40. And so pretty much all of the major manufacturers of smart meters have a model that incorporates Silver Spring's communication technology. And so those can be deployed for these purposes.
Another question for Matt. Say if a customer already has a smart meter, what additional costs would be required to enable telemetry, say for participation in regulation? And how would these vary across residential, small business, and large C&I customers?
Sure. So basically, if the smart meter is already deployed, we provide our Silverlink platform to all customers. And so the only additional cost to enable the telemetry itself would be just turning on that telemetry for that individual customer. Beyond that, you do need to make sure that you have a DRMS or analytics software that's in place to be able to utilize that information either on an real-time basis or offline, depending on how you would envision leveraging it. So there's typically some software that's required beyond that. But if you already have a DRMS deployed that has those types of analytics capability, or other operational system like a ADMS might have some of those types of capabilities, or a DERMS, then it would probably just be simply putting those connections together. There may be some simple integration work that's required to get the data to flow, but we've really designed the APIs to be simply and easily integrated by third parties. And the advantage of having them, many are already moving to adopt our APIs, integrated into their application. And so that once that's done once, the interface would be the same from Silverlink to third parties, from utility to utility. So once those vendors have done it once, then it's possible that they can leverage it for other customers as well after that.
This one is for Brett. Brett, why is DR adoption so much greater in the U.S. versus the rest of the world?
Sure, good question. I'd say there's a couple of reasons. One is the market side of it, and the other is on the technical side. So, and the simplest one is the technical. So it would be the proliferation of advanced metering infrastructure in the U.S. that started with some of the federal funding back in 2008 or so. So there are so many more AMI-enabled utilities and customers in the U.S. that really jump-started a lot of residential DR capabilities, whereas in look at Europe or Asia, they're just getting started really with a lot of their smart meter rollouts for a lot of the countries. So I think once that the AMI expands, then you'll see the DR follow suit. And then on the market side, a lot of the other countries have more traditionally regulated utility structures, whereas in the U.S. we see a lot of the deregulated markets. We certainly have utilities here that are doing demand response from a vertically integrated sense, but a lot of the growth has come from wholesale competitive markets, and then just the idea of allowing the demand side to compete with the supply side and the generation. And that a lot of other areas of the world don't have that type of structure, but again, it is opening up, especially in Europe. You're seeing a lot of countries allow more demand side participation and opening up capacity markets. So I do expect it to expand internationally in the next several years.
Thank you, Brett. Another one from Matt. What communication path is used for the telemetry?
Yeah, that's a good question. And let me just clarify that all of the capabilities that I've been talking about in the second part of the webinar are exclusively delivered via the Silver Spring Smart Grid network. So there's no broadband path required, no cellular, path other than what might be used typically for backhaul as part of the AMI network. And so it's the same communication path that's being leveraged for AMI billing purposes, and pulling that data back into the area. So depending on how quickly the frequency at which you want to pull back the data, 5-minute or 1-minute interval is very typical, but you want to have your interval data for the telemetry be at least on a minimum less than the typical event length that you're going to be calling. So if you're calling half-hour events, then you need your interval length to be less than a half hour. But if you're doing 10-minute intervals for regulation type control or for reliability purposes, then you're going to want to go to a 5-minute or 1-minute interval. So you need to be able to collecting data a couple intervals during the event to get the kind of accuracy that you typically would want to have. And those types of support are only going to be deployed, for customers that are on the DR program. So you're not deploying it for 100% of the AMI customers, but some small subset typically, in the case of the DR use case anyway.
We have another question for Matt. To what extent are you leveraging distributed intelligence and edge computing for rapid telemetry DR?
Today, we're doing a little bit in terms of how we process the information at the edge. We have some intelligent controls to be able to turn it on and off, to be able to look for some information, and all of those things are managed by the Silver Spring communication card. There doesn't need to be any special intelligence in the meter or in the DR device. They're just standard Zigbee devices or standard meters. And we put intelligence into the Silver Spring's communication card that's embedded in those devices to be able to collect that data, to be able to pull it back. Today, that's pretty specific to an individual device, but as you saw in our kind of first vision slide that I put up there, in the long term, we would view being able to also reach out to other types of devices at the edge, being able to pull that information from other areas. So, for example, being able to understand what the current load is in the home from the smart meter, or being able to know what the grid voltage would be from a smart sensor that may be upstream from the device, could be very useful for more distributed type of control. So while that's fairly limited today, we have some good examples of distributed control on the distribution side. I think the industry is still evolving in terms of enabling distributed control for these types of distributed energy resource applications, but we certainly see things moving in that direction, and DR telemetry is one of the core building blocks that's required to really evolve that application and enable those types of distributed applications in the future.
One more question for Matt. Can you collect data at a 4-second interval for regulation?
Typically today, we've been looking at more kind of non-spinning type reserves. This is something that is possible, but where with the non-spin, we can typically do that with the existing smart meter infrastructure that's been deployed for billing purposes. Again, every customer's mileage varies typically, but a 4-second regulation may require some network augmentation to increase the throughput of the overall network. So it's possible, but may require some additional network enhancements to get down to that level. Typically what we do with our customers is to be able to sit down, look at their exact regulation requirements, and then map out the type of data telemetry that they need or require, and then design specific network enhancements if those are required. And so one of the great things about the Silver Spring technology is that you can just increase capacity by deploying additional access points. We also have versions of our smart meter that have embedded cellular communications, so that can create some additional capacity if needed. So we do have some specific solutions, but when you're getting down to that 4-second type of level, typically there's some network backhaul augmentation that may be required to enable it. So we'd be happy to talk with customers in more detail about those ideas.
And with that, we are coming up on the turn of the hour. I'd like to thank both of our presenters. Our guest presenter, Brett Feldman from Navigant. Thank you very much, Brett, and Matt Smith from Silver Spring Networks. Thank you for joining today and for all the great questions. Again, as a reminder, you have the contact information for our speakers today. Please go ahead and reach out to them to follow up with any other questions you may have. With that, I'd like to close. Thank you very much.